Today what we're going to do is we're going to cover two new ways of factoring. So we're going to keep adding to that a little bit. And in order to do that, we have to get on the same page about a couple things. First of all, the first new way is going to be the sum and difference of cubes. So we've looked at a difference of squares before. There is not a sum of squares. There's not a way to factor a sum of squares, but there was a way to factor a difference of squares. With cubes, however, you can factor both a sum and a difference. All right? In order to be able to start recognizing when you have a perfect cube, I'm going to give you a list of perfect cubes. And it looks like this. Okay? In a second. So these are the perfect cubes on the right. So when I take 0 and cube it, 1 and cube it, 2 and cube it, 3 and cube it, I get these. And I want you to be able to start recognizing when you see a perfect cube. You've gotten pretty good at recognizing when you see a perfect square. Okay? Now we start being able to get good at recognizing perfect cubes. And so these are the perfect cubes. And now if you want to take a picture, you can take a picture. You could generate this list on your own too. You can take a picture of this, but if you just took 2 and cubed it, 3 and cubed it, 4 and cubed it, you could come up with your own list on your own if you don't like your picture. Okay? In fact, if you don't like your picture, go back to it later and write them in. Just figure out what those values are. It's no big deal. A couple things to keep in mind. Okay? There are 2 perfect cubes on this list that are also perfect squares. Okay? So you've got to have a sense of the context, the environment that you're in, as to whether or not you're looking for a perfect cube or a perfect square. So a lot of times the variable powers will clue you in onto what the environment is, if it's squaring or cubing, or the other numbers in the problem will tell you whether or not we're dealing with squares or cubes. So keep that in mind. You probably need to know them at least through 125. You should be able to start recognizing 5 cubed. Okay, so beyond that, you'll start seeing 216s and 343s, but they are less common than the 8, 27, 64, 125s. Okay, so those are ones that need to start becoming familiar to you in sort of a different way than maybe you're used to. Now, the formula for factoring a sum and difference of cubes is what I'm going to show you next, and that is something you're going to need to know. I'm not going to provide that for you. Okay? Factoring. So, up top here, we have 2 different situations. We have the sum of cubes. Okay, so this is something cubed plus something cubed. When I factor it out, you're going to need to know the cube roots. So you're going to have to find the cube root of whatever that first one is and whatever the second one is. And notice in the formula, all the numbers are the same. Okay, the first binomial is always the cube roots of each of these, and the sign matches up. So this binomial sign and that binomial sign will always be the same. Same with those. Those will be the same sign as each other every time. And the last sign for the b squared is always positive. The place where you have to be careful is the second sign of each one. They are the opposite of whatever the original binomial sign is. Otherwise, you just kind of follow the pattern the way it's written. Be careful. Figure out a system that works for you to figure out where the plus goes, where the minus goes, that kind of thing. As you work through these more and more, it'll become secondhand, and you'll get good at it, and you won't need to look at it every time. But you have to come up with some kind of system that works for you to keep your signs straight. Okay? Now, the types of problems that we're going to be looking at are things like this. All right, these are the directions that you're going to see. Oftentimes, instead of saying prime, we've said not factorable. Okay, either one of those is okay. So you're going to have problems like this in your homework today, and you're also going to have problems that are equations, the same thing that says equals 0. And if you remember, especially some of you who didn't finish on that one test, remember the backside where it was all solve the equations, and some of you just factored, they didn't keep going and actually solve it. Okay, so remember, if you ever see a situation that says you've got a polynomial that says equals 0, you got to keep going and say x equals 7 or whatever it is. Okay, but if it doesn't, and it's just like this, it's an expression where it just says factor, you're just factoring it. If it says solve, you're finding a value for x. Okay, the process for an equation is really the same. You factor it, and then you have that extra step of solving it. But if I would have put an equals 0 up here, what we're about to do would not be any different until the very end. Okay, so just know that depending on which kind of problem you're looking at in your homework, you may have to take it an extra step and actually solve for the variable. In this case, we don't have to. All right, so whenever we're factoring, the first thing we always have to look for is what? Greatest common factor, right? We always have to check for a greatest common factor. And so make sure that you do that. So just because I'm giving you some new ways of factoring doesn't mean how you start is any different. We're just basically adding to that list of ways to factor. So we still start at the top. Look for a greatest common factor. In this problem, is there a greatest common factor? 2? All right. Discuss amongst yourselves, since there seems to be a little. That was a robust conversation that resulted in the idea that the greatest common factor is 2x. Okay. Now, so I factor the 2x out. Okay? I factor the 2x out, and I'm actually going to ignore the 2x for a little while. It will eventually come back at the end because it doesn't go away. All right? But I'm just going to ignore it for the rest of our time because I want to focus on what's left over. Okay? And so if you notice, 8 and 27, those are numbers that we just had on the other page. Those are, what are those known as? Perfect cubes. Okay? And since they are perfect cubes and x is cubed and y is cubed, I know that each of these are perfect cubes, which means I have a sum of cubes, which means I'm going to follow this formula up top. If it was a difference of cubes, the only thing that would be different would be this minus sign. Okay? And the rest of what we're about to do would only change in terms of the signs. But the mechanics of everything else that we're going to do would be exactly the same. You just have to watch your signs. Okay? That's the first part of it, yes. The first part of it is sum and difference of cubes. No. All right. Now, in order to use this formula, I have to know what a and b is. I have to know what the cube root of ax cubed is and the cube root of 27y cubed is, because I'm going to plug in for a and b, and I'm going to square what a is, and I'm going to square what b is. So what's really important is that I find the cube root of ax cubed and I find the cube root of 27y cubed. I have to find the cube roots of those terms in order to really get myself anywhere. Okay? So what is the cube root? And the way I like to do this is I think of what's the cube root of 8? 2. What's the cube root of 8 cubed? Or sorry, x cubed. X. So the cube root of this is just 2x. What is the cube root of 27? 3. And the cube root of y cubed? Okay. So essentially what happens is this is a and this is b. And so I'm going to plug in everywhere I see an a, I'm going to plug in 2x. Everywhere I see a b, I'm going to plug in 3y. Okay? Nope. Don't worry about plus or minuses. Okay? The formula takes care of all that. So look at it from the perspective. So if this would have been minus, I would still want you to take the cube root of 27y cubed, and the formula takes care of fixing the signs. Okay? Now, so here's what that's going to look like. Eventually in this section, yes. Okay? Now, so notice here, so in other words, what I have here is I've rewritten it in terms of its A and B. So in reality, this is A, this is B, 2x. And now I just plug in. Everywhere there's an A, I plug in 2x. Everywhere there's a B, I plug in 3y. And so here's what that's going to look like. I even color-coded it for you. So in this, we're using this top formula. And again, the formulas are the same. The numbers are the same. The mechanics are the same. It's the signs you have to watch. So in this top one, the first sign's a plus, the second sign's a minus. So it always goes plus minus or minus plus. And then the last term's always plus. Okay? So notice that these are opposite. If that helps you try to keep it straight, these line up, and then the next sign is opposite that. Okay, so I take that A and I square it. When I get 2x and I square all of it, what do I get? 4x squared. When I multiply these together, what do I get? When I square all this, what do I get? Okay, here's what I've got so far. Now keep in mind, all of this is just this part. I still have this 2x that still needs to be there. It doesn't go away. Now the one thing that's interesting about sum and difference of cubes is that this trinomial is never going to be factorable. Which means if this was an equation, we'd have a quadratic that we would solve that would not be factorable, which would mean we would have to use the quadratic formula, which is what we're going to do on Monday. And that's where the imaginary numbers are going to come in. Okay? Yes. So then the last thing is that 2x down. So I bring that 2x back into play because I wasn't using it. It was still there though. And that is factored form. That is the answer. If. Right, and it's because of that trinomial. That's never factorable. Now, if this was an equation, and this would have said equal 0, once I get it into its factored form, I'd have to take 2x, set it equal to 0, 2x plus 3y, set it equal to 0, all of this and set it equal to 0, solve each of those. You can't set each of those equal to 0 and solve it when there's more than one variable. If there's only one variable, you could actually solve it. But of course in these, since I have y's, I'm not going to be able to actually solve them if it was an equation. So if it was an equation, it would probably not have the y in it at all. It would be like if I just dropped the y's out and then I set it equal to 0, then I could solve it. Okay? But that's what we're going to be doing. We're going to be doing more of that on Monday, but there's going to be a little of that in your homework today. But again, like I said at the beginning, if it says equal 0, from here you just take it that next step, set each of those things equal to 0 and solve them. Okay? So again, with the difference of cubes, everything that we just did is exactly the same. This would have been a minus, this would have been a minus here, and this would have been a plus. Everything else would have been the same. Okay, so I'm not going to do another one of those. So that's sum or difference of cubes. What I recommend is when you go to do your homework, you put this formula at the top of your homework. Okay, that way it's right there to reference. As you get used to using it, you'll commit it to memory more. But again, that is something you need to know. I'm not going to provide for you. Next type of factoring is factoring by grouping. Now, some of you have already been using factoring by grouping. Some of you have been taking your trinomials and turning them into a polynomial with 4 terms, and then you group them, which is fine. Okay? If you haven't been doing that, this is going to be new to you. Okay, the box method is really a way of grouping. Here's when we use it. When there's 4 or more terms, we use grouping. Before today, the only way that we could factor anything with 4 or more terms was by greatest common factor, and that's all we could do. Now we're going to look at this method to see if we can take it a little bit further. So, first thing is you're going to group the first half of all the terms together and treat it like it's its own problem. And we're going to go through 2 examples on this one. So I group them together, treat it like it's its own problem, and factor it. So here's where your copy and paste is going to come in handy, because what do you think the second step is going to be? Do the second half, yeah. Group the half together and factor it like it's its own problem. So essentially the same. You're going to essentially create 2 new problems. And then we're going to merge them together. Okay? And then what should happen is when you factor the first half and you factor the second half, there should be something in common between the 2 halves. Okay? And that's what this says. So there should be a group in common between the 2 halves that we're going to factor out, and then we can simplify it from there. And when we do this first problem, I will do the first one and talk you through it, and then I'll give you one to try. Here's our example that we're going to look at. 6 terms. Like I said, 4 or more terms. So if you had one like this that only had 4 terms, you could still use grouping. I mean, the thing that's nice about this problem is that the middle sign is a plus sign. And as we know, the difference between a positive number and a plus sign, I don't need to worry about it. If that middle sign is minus, which the next problem is going to be, it creates a little bit of a problem that you have to watch out for. Okay? And let me show you what I mean. So first of all, when I group the first half, since there's 6 terms, I can just group them. And that just means throw parentheses around them and treat them like it's its own group. And then I can do the same for the second half. The reason that the minus sign creates a problem is if you notice here that I put the parenthesis in between the plus and the 6. If that middle sign was a minus and I put a parenthesis in between them, I would have changed the number. Okay? And I don't want to do that. I want to keep the sign with the number. But because it's plus, which makes it positive, I don't need a sign in front of the 6 to know. We all know that 6 by itself is already positive. So that's why I can put it in between the plus and the 6, because it doesn't change the value of positive 6. It's still positive 6. On the next problem where it's a minus in the middle, if I put that parentheses in between, it would change the problem. We don't want to do that, and I'll show you how to deal with that. All right. Now, here's what we do. So I've got this first sort of new problem. Okay, and I'm just factoring it. So what do I check for? Okay, what is the greatest common factor here? 4x. So I pull out a 4x. Okay, and so what am I left with? Okay. Now, you check. You definitely want to give this a check and make sure there's not anything else still in common or there's nothing else that we can do. And there isn't, so I'm good. Okay? If there was, then you'd have to go back and do it over again. Now, as you enter into the second part, understand this. Your goal is to have another 2a plus b plus c. We want this to happen again over here. If it does, then we've done it right, and it's factorable by grouping. If it doesn't, either we've done it wrong, or it's not factorable by grouping. So when I look at the second part, what is the greatest common factor over here? 3y. So I pull out the 3y, and here's where that plus comes in. It's that same plus that's still there. Okay? What's left over? Okay? So it worked, right? I got the same thing, which is good. So that's the first 2 steps. That's the first 2 steps. Now there should be a group in common between the 2, which we just have been talking about, and there is. 2a plus b plus c. They have a group in common. So in reality, what I'm going to do now is I'm going to treat that group like a greatest common factor and factor it out of the whole thing. So what I end up with is this 2a plus b plus c. That's like the greatest common factor. And when I take it out of this first term, what's left? 4x. When I take it out of the second term, what's left? 3y. Okay? So that's what I'm left with. Take a look at it again. Okay? So once I get it to this point, essentially what I'm doing is I'm taking out the common group. Instead of a common factor, thinking of it as a common factor, think of it like a common group. When I remove it or divide it, each term by it, I'm left with the 4x, and I'm left with the 3y, and that's why you see the 4x plus 3y there. Now it's factored. Now I'm done. Again, if it was an equation that said equals 0, I'd set each of these equal to 0 and try to solve them. Okay? That is the answer. Okay? So let's work on one. Let's try one. I want you to try one. Okay? So, can I switch to the next slide? Yes. All right. In this problem, as I mentioned, the middle sign is minus. This is where we have a problem. So I'm gonna set it up for you, and then I'll let you do it. So factoring the first one is no big deal, or grouping the first one is no big deal. Okay? And I can start grouping over here. Here's where I have my problem. If I put a parenthesis in between this minus and the 5, I've changed it from -5. You need to think about this as -5. No, so we don't want to do that. We don't want to do any of that. What I want to do is slide that minus inside and add a plus sign. So we know that plus a negative is the same as minus. So that's the only difference. Okay? When that middle term is negative, we need to slide it inside the parentheses and add a plus sign. From there, everything is the same as what we did on the previous slide. So you do it. So one of the issues that some of you are having are with this second set, okay? So this first set, what is the greatest common factor for the left side? 6x. So I take the 6x out, and I'm left with 5a minus 4b plus c. Now, again, if you remember, when we did the other problem, you have to understand that we're trying to get this to happen again. Okay? So there's two ways to approach it. One, when we started factoring, I said when that first term is negative, you want to take out a negative. And the first term is negative, you want to take out a negative. But let's say you didn't remember that. If you remember that I'm trying to get a 5a again, I need to take out everything that will turn this into 5a. So I got to take out the minus, and I got to take out the y squared. So now I got to check, is there a y squared in all the other ones? Yes. So if I take out a minus y squared, that will leave me with 5a minus 4b plus c. So the signs all change when I take out a negative, which is good because that second group is now the same as the first group. Okay? So my common group is 5a minus 4b plus c, and whatever's left, 6x minus y squared. How many had that? Very good. Okay, so your problems today, again, I'll say this one more time. If this said equals 0, you would have to keep going and solve them. If you have a problem, because you're going to have some like this, you're going to have some equations. Whenever it says solve, you have to go down another step and say x equals. So once you get it into factored form, set each set of parentheses equal to 0 and solve it. That's the only difference between the factoring problems and the solving problems. Okay? The method's going to be the same. You're just going to have to extend it a little bit further. All right. That's what you've got today. Monday, we're going to look at the rest of 5.5 and look at some other ways of factoring with similar methods that you've already used. So on Monday, we're going to keep factoring. The methods are not going to be new, but the problems are going to be more complicated, and we're going to apply the methods that we already know to more complicated problems.